All right, good morning, Tigers. This is our video lesson for lesson 2.2, solving equations. We're getting into equations that have variables on both sides. I really like this lesson because it's basically one big problem that you have to solve instead of a bunch of little bitty practice problems. Okay, so first thing we want to do is annotate our learning targets. Now these are the same learning targets as in lesson 2.1. So go ahead and start circling verbs, underlining nouns. Be able to use units to understand and interpret problems. Choose and interpret an appropriate scale for a graph. Explain each step when solving an equation. Construct a viable argument for choosing a solution method. Solve a linear equation with one variable. And solve a literal equation, which again, this is coming at the very end of this unit. Okay, and then double check. I know your correlating learning tasks I think are a little more updated than mine, and that's okay. Everything else should be the same. Okay, so let's jump into our problem. So we have, so the engineering club at a local high school wants to raise money for a field trip to the Science Museum. The club members will hold an engineering contest to raise money. They are deciding between two different contests. There's a Strawbridge contest and a card tower contest. The Strawbridge contest will cost the club $5.50 per competitor, plus $34.60 in extra expenses. The card tower contest will cost $4.25 per competitor and $64.60 in extra expenses. All right, so task one, we're going to look at some problem-solving strategies and setting up our equation. So to help decide which contest to host, the club members want to determine how many competitors they would need for the cost of the two contests to be the same. So how much each of these cost depends on how many competitors you have. So it's a fundraiser. You want to make the most money. So we want to set up an equation so we know at what point does it not matter? Like how many competitors will they be the same at? Because one equation is going to be better for one scenario and one equation is going to be better for another. So I want you to take a minute and fill in table number 1 with things that you know and with things that you need to know about each contest. So go ahead, pause the video, and fill in some ideas. Okay, so I jotted down a few things that we know. For the Strawbridge, we know that we're going to have to pay $34.60 for extra expenses, and then for each person that competes, it's going to cost us $5.50. For the card tower, we're going to have to pay a total of $64.60 in extra expenses, and then it's going to be $4.25 per person. So let's look at it. So this means that our upfront expenses are cheaper here, but per person is more expensive. Here it's more expensive, our extra expenses are higher price. It's going to cost us more here. But when we start adding people, it's going to be much cheaper per person. So at some point, we want to know how many competitors will it cost us the same no matter what. And we want to know overall for how many competitors we're going to have, which one is going to be cheaper for us to run. We want to pick the cheapest, the one that's going to cost us the least amount of money for the competitors we have. So we need to figure out how many competitors are they the same. So let's look. So we want to write, let's write an expression for each one of these. So I want to know, I know I have to pay $34.60 no matter what. And then for each person, I have to add $5.50. So I have to add $5.50 if I have one person. I'll have to add that twice if I have two. I have to add that 3 times if I have 3. So I'm actually going to take this and multiply it by my competitors, or by the number of people I have. So let's use P for people. So, and we want to define that. We want to write this out to the side. So let's put it up here. P is for people competing or competitors. Okay, so 3460 plus 550p. Now let's do the same thing for here, and it should follow the same format. We're going to have to pay the 6460 no matter what. That's all of our materials and stuff. And then per person, it's going to be $4.25. And so we'll have that times P because that's going to increase with each person. All right, so step 2 says write an equation that sets the cost of these two contests equal. So this is the cost of the straw bridge. This is the cost of the card tower. I want to know when those two costs are equal, when this expression equals this expression. So when you have something that sets blah blah blah, or sets the two equal, you're going to take your two expressions and put an equal sign in them. So 3460 plus 550p is equal to 6460 plus $4.26p. Okay, then it says solve, showing each step. You may use an undo list if you like. Okay, so let's start with that. Let's go ahead and write our given. 3460 plus 550p equals 6460 plus 425p. Okay, so when we go to undo this, first thing I want to do is what's being done to the p? Well, I've got a p here and a p here. So it's going to be really, really hard for me to say, well, I don't know if I'm multiplying p by 550 or if I'm multiplying p by 425. So what I'm going to do is I'm going to use my subtraction property to get this over to this side. So let's do that. We want only one set of p. We only want to deal with one variable. So what I'm going to do is I'm going to take the smaller of the two. Now you can move the 550p over and that's fine. You will get the same answer. But if we move the smaller number over, we're going to subtract it because that will cancel. If we move the smaller one over, we have less negative numbers to deal with. Our number is smaller. If we were to subtract our larger number and move it over, we'd end up with a negative. It'd be the same, the absolute value would be the same, but it would be negative. And that's kind of a pain. So we're going to do 3460 plus, by subtract, we get 125p equals 6460. And then we can do our do and undo list here. Okay, so what am I doing to p? The first thing I'm doing is multiplying by 125. And then the next thing I'm doing is adding 3460. So to undo it, I'm going to take this over here. We're going to subtract 3460 and divide by 125. Okay, so let's do that to this equation. I'm going to bring this down here. We have 3460 plus 1.25p equals 6460. All right, so first thing I want to do is subtract by 3460. Okay, Okay, that cancels. We're left with 125p equals 30. And you put 0.00 if you want. Okay, then we want to divide by 125. And p is going to equal, let me do my calculator, 30 divided by 1.25. P is going to equal 24. So my solution is P equals 24. And what does that mean? What does that P equals 24 mean? Well, that means the contests have the same costs if, let's speed this up, if 24 people compete. All right, so the costs are exactly the same for 24 people. So if I know I'm going to have exactly 24 competitors, I can go with either contest and it won't cost me as much. It will cost me the same amount of money. Okay, so we're going to go ahead and go to the next page. Okay. Number 3, interpret the meaning of the variable and its value in the context of the problem. We just did that. So P means people competing. P equals 24 means